Welcome back. In the previous lecture, we understood about how do you work with booleans in Spark. As a part of this lecture, we'll try to understand how do we work with numbers. So instead of being a one-way communication, let us go on asking some questions and trying to answer them. Can you think of what are the different things you can do with the numbers? Pause a video and try it out. One thing is you can count, right? You can count the numbers. Anything else? Yes, we can add the numbers. Isn't it very simple? So I can add the two numbers. What else we can do? We can subtract two numbers. What else we can do? We can multiply, we can divide the numbers. What else we can do with the numbers? Apart from all these things, whatever we have seen. Any other things? One thing is we can round off. Rounding off is very common thing when we are trying to do a data analysis, because most of the calculations wants the rounding off to be done. The next thing is we can try to find the minimum of a particular number. When we are trying to deal with a large amount of data, we can try to find a minimum. The second one is we can try to find the maximum of the numbers as well. What else we can do with the numbers? Isn't it getting crazy? One of the thing is you can calculate the mean of the numbers. The second thing is we can calculate the standard deviation of a particular column. And we can also find the correlation between the two variables. We can do all these things as a part of dealing with the numbers. Now let us take a scenario. The scenario is one column you have a string and another column you have a numerical values. If I ask you a question, which of these columns we can do all the computations what we mentioned above, like addition, subtraction, multiplication and finding a mean and all those things. What else you can do? I know it is a simple question. So most of the things are simple, yet we need to know all of those things. We'll be able to apply the above computations like addition, subtraction only on the numerical columns. Can we apply the computations for the columns which are string? It doesn't make sense. What it does is it will try to compute the ASCII values. So whenever you are trying to do some of the computations like addition, subtraction and all those things, it is better we stick to the numerical columns rather than some other columns. Let us try to see the arithmetic computations. Imagine a retail data set. In the retail data set, assuming that computation between a quantity and unit price has gone for a toss. That means what are the computations what we have done is not proper. How do we fix that? We can use all these computations like addition, subtraction, multiplication and divide and fix that issue. How do we do that? Very, very simple. So what we can do is we need to mention the data frame name, okay, as usual, and we can include all of these computations as a part of the select expression. As you know, we have already seen how we can deal with the select expression. We'll be able to provide a column name or select a column. Along with that, we can have an expression as well. That is what we are trying to do here. As a part of the expression, if you see what we are trying to do here is, we have a one column, this is a column name, the quantity is a column, and we have another column called unit price, one more column. This is column 1, column 2. We are trying to multiply the values of these two columns and we are trying to take a power of that particular result. Then that result will be added with number 5 and this whole computation would be renamed as a one more column called real quantity. This is how we are trying to work with the numbers in Spark. Now that we understood addition, subtraction and all that, it is simple, but how do we really implement that syntactically in Spark is important. That is the reason we are trying to take that example and trying to explain you guys. Now that we already know, we can do the rounding. What and all we can do as a part of the rounding off? We can do two things. One is round and B round. What happens as a part of the round? Assuming that you have a number called 2.5. In case of round up, this will be rounded up to 3. In case of B round, all it happens is, if the number is same number 2.5, it will be rounded down to 2. That's all is happening. But is it so simple? Why are we trying to deal with it? This is one of the important thing, especially when we are trying to do with the retail domain and also any of the domain for that matter. Rounding is also one of the important computation or important operation which we need to do on the numbers. How do we do it? First and foremost thing is import this function round and B round. This is a data frame, and in this case we are trying to select. We already know lit is a function through which we can pass the values into the data frame. We are trying to pass a value 2.5, and when you say round, it will be rounded up. And the next thing is we have a B round, where what we are trying to do here is we are trying to pass a value 2.5. In a B round, what happens is it will be rounded down. Isn't it simple? Yes, it is. Whenever you are trying to deal with the numbers, you would need a statistical summary of all the columns. If you were to compute all the numerical column statistical summary, you may have to include functions in isolation. Instead of doing that, Spark has provided a wonderful function called describe. This describe function would compute mean, standard deviation, count, minimum and maximum. All you have to do is use a data frame name and just use a describe. You will get all these 5 measures computed for you for all the numerical columns. Isn't it great? Yes, it is. The next one is correlation coefficient. What is correlation coefficient? Whatever the functions we have seen so far are the functions which will deal with the single column. Pay attention. Whatever the functions we have seen so far, all of them are computing some measures for a single column. But there are scenarios where you need to understand the effect of one column over the other column. How values of one column is impacting the another column. That is where correlation coefficient comes into picture. Coefficient correlation is a numerical measure of correlation, meaning statistical relationship between the two variables. Variables being the columns here. That's it. And this is also called as Pearson correlation coefficient. As I said, if you take a same example of a retail data set where we have a 2 columns, one is a quantity and second one is a unit price. If you have to see how quantity is correlated to the unit price, assuming that you are going to a retail shop, either Walmart or More or Big Bazaar or any of the retail shops or a Target or any of the retail shops. If you really remember, when the price of an item is around 30 cents or 5 rupees or 1 or 2 rupees, then you tend to buy more number of items. What it means is, whenever the price is going down, the quantity is going up. That means, how are they correlated? They are negatively correlated, isn't it? One variable is going up, another variable is going down. They are negatively correlated. How do we get the correlation coefficient between the two variables? Very simple. Spark has made it very simple for you. All you have to do is import a correlation function. You can use it in 2 ways. One way is data frame name, and it is a stat function. Call a correlation and give the column names between which you want to find a correlation. That is one way. And another way is you can specify a data frame name, use a select correlation. It is an expression. Then please give a columns between which you want to find a correlation coefficient. We will see how to work with the numbers as a part of our hands-on exercises. So let me log into my Ubuntu. I'm there. My PySpark terminal is available. So we'll work on the same retail data set what we have been using for when we work with the booleans. Let me go ahead and say now, as I said, we need to understand how do we use the addition, multiplication, and all those things. Let me go ahead and show you print schema so that you understand what are the columns here. There are 8 columns here. We can try to multiply the quantity of the unit price. Assume that something has gone wrong. We are trying to fix that. TF retail. So we'll try to use a select expression. We can select some columns and also power quantity. Quantity is one of the column as we have already seen. Multiply that with unit price. And then whatever the outcome we are getting from multiplication of these two columns will raise it to the power 2. Then add some number, let us say some 10. What we will do is we'll try to save this as a different column as a real quantity. This is how I'm trying to use multiplication, power, addition, all these things. This is how we can work with the numbers. Okay. There you go. We have chosen one column and quantity and unit price is multiplied. That is raised to the power of 2. Then we are adding 10 to that. We are saving this whole expression as a column called as real quantity. This is how we use the arithmetic operations. So now one of the important thing is rounding off. So what we'll do is we'll just use the lit function. On the lit function, we'll try to, and I'll say lit 2.5. Try to copy this whole thing, and okay, I'll just say b round here so that I can round down, and then we'll execute this. You can see it, right? So round is rounding up, 2.5 is rounded up to 3, and b round is rounding down if the value what we are trying to give is in the middle, that is 2.5. This is how we can use the round and b round. Then next what we will do is how do we find all the statistical summary? Very simple. Df retail, and I'll say describe, and then show. This will calculate the statistical summary. There you go. Look at this. So it is calculating the statistical summary like count, mean, standard deviation, min, and max of each of the column, invoice number, stock code, description for all the columns. The next one, what we will do is how do we really calculate the correlation between the two columns? That is also very simple. But only thing is we have to go and import a function dot SQL dot functions import correlation. Then all we have to do is df retail. There are a couple of ways you can execute. One is stat corr, then give a column. In this case we want to get the correlation between quantity unit price. And when we use this, no need to use the show here, because if you use the show it will give a error message. It's a floating number, will not be able to display it because we're using a statistical function here, that is correlation. There you go. The correlation between the quantity and unit price is minus 0.0411. What it means is quantity and unit price columns of a retail data set are negatively correlated. The extent of negative correlation is shown here. The next way we can also execute this in a bit different manner. Let me try to revisit this df retail, and what you can do is instead of using a stat, all you can do is and use a select, then within that select correlation, then quantity. That's it. Okay, we are there. Let me go and execute this. There you go. So this is one more way of executing. We have learned how do we work with the numbers by using addition, multiplication, and finding the correlation between the couple of columns. Please do practice all these things as a part of your exercise. Thank you.